So in this video we will be doing limiting factor question from the Kaplan kit of F5. So question first is if the strike goes ahead, which product or products should be produced if profit are to be maximized? So let's read out the scenario. A company has a following production plan for the next 4 weeks and the figure reflect the full capacity level of operations. Planned output is equal to maximum demand per unit, means whatever the planned output given is equal to the maximum demand per product. And the direct labor force is threatening to go on the strike for 2 weeks out of the coming four. This means that only 2160 hours will be available for production rather than the usual 4320 hours. It means the labor is our here limiting factor. So before moving this type of question, what we have to do is, first of all I will write down what kind of product we are producing. We are producing A, we are producing B, we are producing C, then D. And what is the contribution of product A is 46, and similarly for B is 52, 13, 8, 21, and for D is 48 plus 2. Okay, so I have done this in the shortcut, or you can do like selling price minus all the variable cost, you will get the same value. Okay, so now what's our limiting factor is? Limiting factor is our direct labor, and how many labor is required to produce, a labor hour is required to produce the 1 unit of product A. So we do have given the labor cost, and just wait. Yeah, we do have given the labor direct labor hours per unit below the output, and which is 6832. So our contribution per limiting factor is just dividing contribution by limiting factor and copy, shift it over here. Okay, so we will rank, and which is the highest contribution for the it's for the A. So first, then after no first is D, it's having a contribution of 30, and then after it will comes to product A, then C, after that product B will rank last. Okay, so according to this we will plan our optimum production plan, I mean schedule our optimum production plan. Okay, so how many labor hour is available? So labor hours available is 2160 hours due to the strike which the labor are going to take, right? So we do have it 2060 hours. So first we will produce the product D, and how many hours will require to produce the product D? So 1 unit of product D requires 2 hours of labor, and what is the unit? It's 400, so it means 800 will require. So remaining direct labor hours will be this minus this, so 1360 hours will be remaining. After the D, we will manufacture or produce product A, and product A requires 6 direct labor hours. And how many units the product A have? Maximum output, maximum demand is 300, so 300 we will do 1800. So product A will require 1800, but we do only have it 1360 hours, so we can't produce the whole maximum demand of the product A. So what we have to do is take this hour and divide by the how many hours labor hours required to produce the 1 unit of product A. So it's I mean 6 in our case, so it's 2267. Okay, so we can only produce product A and D, we can't produce B and C because of due to the labor being going on the strike. Okay, so hope this is clear to you. Okay, so moving ahead, our next question is, what is the number of unit of product Y produced in order to maximize the contribution to the nearest whole unit? So let's read out the scenario. The organization has the contribution function. So contribution function is given. So if we will get the value of X and Y and put it here, it will maximize our contribution. Means this is our maximum contribution by we will get by selling this unit, where X is the number of unit product X produced and the number of unit of product Y produced. A graph has identified the optimal production plan exists at the point where the following two constant crosses. So skilled labor hour, unskilled labor. Okay, so constant has been given. The maximum demand for of the 12,000 unit of each product. There is maximum demand of 12,000 unit of the each product. So from this constant, so how many equation we can form? So let's see question number 98. So first equation will be for the skilled labor. Okay, and that's a 6x plus 4y equal to 62,000. So this is our equation 1. And unskilled labor, so unskilled labor will be 2x plus 5y equal to 50,000. Okay, so apart from these two, we can still form the two more equations. So question told there is a maximum demand of 12,000 unit of the each product. It means X is equal to 12,000 and X is our number of unit of product X produced. Again, demand for the Y is 12,000. So these so we do have all together 4. Okay, now question told the optimum solution can we find when these two constant cross each other. So it means we have to solve these two equation, and I hope you guys have a basic knowledge how to solve this equation. We all have been read this in our class 7 8 in the algebraic portion of the mathematics, right? So we have to solve these two equation in order to get the two value of, I mean, one for the X, other for the Y, and that's our optimum production plan. Okay, so for solving we will multiply unskilled labor. So I will multiply it by 3. And how I think I should multiply it by 3 in order to make that 6, so that I could, if I could subtract these two equation, 6x will be get cancelled out. Okay, so I think you guys know the basic things of how to solve the equations, so I'm not going to detail in those part. So okay, so multiply it by 3. So multiplying means unskilled labor, I'm multiplying unskilled labor equation by 3. So what will be the revised equation? It will be 6x plus 5 3 is a 15 y equal to 50,000 into 3. It means 150 1 2 3. Okay. Okay, so now I am subtracting skilled labor equation from unskilled labor. Again I am repeating, I am subtracting skilled labor from unskilled. So what's the unskilled labor equation? 6x plus 15y, and subtracting skilled one. So 6x, so bracket will be open, so it will be 4y now. 4y equal to 150,000 minus 62,000. Okay, so 6x will be get cancelled out. So 11y will be remaining here and equal to, so 150,000 minus 62,000. So y equal to your this divided by 11. So it means 8,000 of y need to be produced. And what's the value of X? So you, if you put the y equal to 8,000 in any of the first two equation, you can get the value of X. So I will put it in the first equation of the skill level. Okay, so 6x plus 4 into y value is 8,000 equal to your 62,000. 62 thousand. Okay. Okay, so now 6x equal to 62,000 minus 32,000. So x equal to this divided by 6, so I got 5,000. Okay, so now question told only for the y. What is the number of unit of product y to be produced in order to maximize the contribution? So we already got our answer earlier, so we don't need to calculate for the x. So 8,000 is the unit that need to be produced for the y. Okay, so next question, which of the following is our slack resources? Okay, so jewelry company makes a rings and necklace. Okay, resources available to the company have been analyzed into two constants have been identified. One is the labor time, other is machine time. The management accountant has used linear programming to determine r equal to 500 and n equal to 400. So this is our optimum production plan. So which of the following is slack resources? So in order to get the slack resources, what we have to do is question number 99. Okay, so first of all, what's our two constant and converting those it into the equation? So first is labor time, right? And what is constant is it's 3r plus 2 and I'm converting it into the equation. Be careful, if there is greater or equal to sign like this, it's a constant, and if you will only put equal to sign, this is the equation. So 2400 hours, and other is machine hours, right? And 0.5 r plus 0.4 and equal to 410 hours. Okay, so now we have a optimum production plan calculated by the management accountant using the linear programming, so we don't need to get it calculated again. So 3 r is your 3 into r is 500 and 2 n is 400. So by putting this value, putting the value of r and n in this equation, how much we got? We got 2300. But how many hours are available? 2400 hours are available, right? Again we are putting the value of r and n in the second equation of machine hours. So r is 500 and n is 400. Just a second. Okay, okay, so and value of n is 400, so it's a 410. So both are equal, it means required hour and what we had required hour to produce r and n, and what is the available, both are equal. Okay, so there is no slack present in the machine hours, but in labor time there is still slacks of 100 hours. Okay, so labor time is only the slack. So basically slack is unused resources, you can think. Just wait. Okay, so our next question is, what is the shadow price of these materials if the material were limited to 200 kg per week? So before reading this scenario, I would like to say we can solve this question by the two way, and I will explain you the both way of solving this question. Okay. Okay, so question number is 99, right? Okay, so question number is 99. Okay, so let's read out the scenario. The QPLC make it two product, one is Q1 and other is Q2. So for Q1 product is Q1, Q-U-O-N-E, Q1, and other is Q2, Q-U-T-W-O, Q-U-Q-U-T-W-O. Okay, and so name is quite difficult to produce, so I will change the name. I will keep A for the Q1 and B for the Q2. Okay, so okay, the QPLs to make two product and from same raw materials, the selling price and the cost detail of this product are as follows. Okay, selling price, direct material, direct labor, variable overhead, all are given for the both the product. Contribution is also given. So maximum demand of this product is 500 unit per week of Q1, and the unlimited number of unit per week of the Q2. What is the shadow price of the material? Well, material will limited to 200 kg, 2000 kg per week. So here material is limited, it means material is limiting factor, or we can say the scarce resources. So let's make a equation. The first step, for how many material is required to produce 1 unit of Q1. So we do have given the total material cost per unit and the cost per kg of the material. So by dividing these two, we can get how many materials are required to produce 1 unit of Q1. So 6 divided by 2 is 3, and for B, 5 divided by 2 is 2.5. Right, so we can form a equation. So equation will be like 3, and as I given the name A for the Q1 and plus 2.5 and B for the Q2, so equal to 2000 kg, because material is our constant here, or we can say limiting factor, scarce resources, right? And other thing, the question told that the maximum demand for this product is 500 unit per week for Q1. Again for the Q1, it means A equal to 500. Okay, so an unlimited number of unit per week for the Q2. So Q2 have an unlimited number of unlimited number of units, so we don't have to make equation for Q2. So now other equation we have to make is about the contribution function, and the contribution is 8 for the Q1, 8A, so plus, and 8.50 for the Q2, so it's B. Okay, so we need to maximize first of all we need to calculate the optimum production plan. It means how many unit of A and B will be produced so that our contribution will be maximized. So C equal to, and I will write it here, this is a contribution function, and our objective is to maximize this, right? So first of all, if we will solve these two equations, just have a look on the screen. If we will solve these two equations, we can get the value of A and B. The value of A is already have been found, so we can get the value of B. So I will calculate it over here. Okay, so 2000 minus 3A. So 3A means 3 into 500, 1500 divide by 2.5. So we got the unit of how many unit of B need to produce in order to maximize the contribution. So our original contribution equal to 8 into A is 500, and 8.50 into B is 200, so it's 5700. Okay, so now what the shadow price is? Shadow prices means if the scarce resources or limiting factor resources, whatever it is, like in our case is material, if one more additional unit of material you will get, by how much your contribution will be increased, and that increased amount of contribution is your shadow price. Okay, so I hope it is clear. So let's suppose we have one more unit of scarce resources is available. So now our equation will be like this. So it will be 2001. So it means 1 kg 1 kg of additional material is available. So by how much your contribution will be increased, we have to calculate this. Okay, so again finding the value of B equal to, so it will be now 2001 minus 3 into A means 3 into 500, it means 1500, divide it by 2.5. Okay, so we got the value 200.4. Okay, so now putting this value into the contribution function, so now our new contribution will be new contribution will be 8 into A is 500, and 8.5 into B is 200.4. So our new contribution is 15703.4. So what is the increased contribution? Increased contribution is equal to shadow price. Shadow price, and what is that in our case? Wait. Okay, so this minus this, so this is our shadow price 3.4. okay. So another way of doing this question is, it's quite simple. So what you have to do is, what is the contribution, just wait. Okay, so maximum demand for the Q1 is given, and there is unlimited number of unit for so maximum demand of this product is 500 unit per week of Q1. Okay, so maximum demand for the Q1 has been given, and there is unlimited number of unit per week for the Q2. Okay, so we can calculate like this. Just a bit. Okay, so other method is, I will explain. Okay, so Q2 have a unlimited demand. Okay, so and if we will rank these two product according to the contribution per our scarce resources, what will be that? Product is, first of all, so product is okay, and so contribution is limiting factor is 3 2.5. So contribution per limiting factor is this divided this. So okay, so C have a, Q2 have a maximum contribution, so the highest contribution per limiting factor, so we will produce the Q2 first, right? And Q2 is having the unlimited demand, so if we will produce the Q2, the whole limited resources will be spent on the Q2. Okay, so you can see, so 3.4 contribution per limiting factor of the Q2, or in case now suppose कि if the Q2 have a maximum demand, in case अगर Q2 का maximum demand होता, so and यहाँ पे हम लोग ने प्रोड्यूस कर मैक्सिमम डिमांड एक स्पेसिफाइड यूनिट, जैसे यहाँ पे 500 Q1 के लिए दिया हुआ है, तो Q2 को इफ सपोज Q2 का 500 मैक्सिमम डिमांड होता है, तो हम लोग Q2 प्रोड्यूस कर लेते हैं, तो Q1 पे आके हमारा मटेरियल खत्म हो जाता है, राइट? सो इन दैट केस कंट्रीब्यूशन पर लिमिटिंग फैक्टर ऑफ Q1 जो होता है वो हमारा शैडो प्राइस होता है. अगर ये आपको इफ यू आर फीलिंग दिस लाइक सेकंड वन मेथड इज क्वाइट कॉम्प्लेक्स, यू कैन गो फ्रॉम द अबव वन, सो इट इज क्वाइट सिंपल, आई थिंक, आई गेस. ओके, सो यहाँ पे हमारा सेकेंड वाला मेथड में Q2 का कंट्रीब्यूशन पर लिमिटिंग फैक्टर इज आवर शैडो प्राइस. And why so? Because Q2 have a unlimited maximum demand, so if we will get one additional kg, it will enable us to produce how many unit of Q2. So अगर एक आवर्स चाहिए तो कितना यूनिट प्रोड्यूस करेगा? So एक आवर, आई थिंक 1 kg, so इस रिक्वायर 1 divided by इतना, so 0.4, and contribution it's ये जनरेट कर रहा है, that's 8.5, so ऐसे करने पे भी 3.4 आ रहा है. ठीक है, ओके. सो नेक्स्ट The shadow price of a skilled labor for CVV is currently 8 per hour. What does this mean? So basically, shadow price is the your you can say the additional amount we or maximum over premium, you can say, okay, over the existing amount that you can pay. So let's read out the first option. You can get to know what the shadow price is. Otherwise, in the book is written the definition is, I can read it out. It's increase in the contribution created by the availability of one additional unit of limiting factor at the original cost. So shadow price, the cost of obtaining additional skill labor resources is 8 per hour. Never it the cost of obtaining additional skill labor resources will be 8 plus the whatever the existing rate we are paying to labor, not the 8. It's only the additional or increment amount over the existing one, or incremental contribution, we can say. There is a hidden cost of 8 for each hour of skilled labor actively work. It's not a hidden cost, okay. Contribution will be increased by 8 per hour for each extra hour of skill level that can be obtained. Obviously, as I have been calculated above, the shadow price is the increase in the contribution, you can see. So obviously shadow price is the increase in the contribution uh, for the extra hour of skill labor hour that can be obtained. Total cost will be reduced by 8 for each additional hour of skill labor that can be obtained. The total cost will increase by 8 for the additional hour of skill labor. Okay. So next question is 102. What are the most and least profitable use of direct labor scarce resources? So the following details relate to the three services provided by RST company, and so service they providing is, one is RST, and fee charged to customer is 100, 150 and 160. It means it's a selling price, and unit service cost given including variable and fixed cost. All these services use the same type of labor which is paid 25 per hour. It's the rate given, and fixed overhead are generally fixed overhead that have been absorbed on the basis of a machine's hour. Okay. So first of all, selling price we can say for the R is 100, 150 for S and 160 for T. So first of all, we need to find out contribution per service. Okay. So direct material is 15, 30, 25. Direct labor is 20, 35, 30. Variable overhead is 15, 20, 22. So now contribution per unit, I'm writing in the shortcut. So it will be subtract all the variable cost from selling price. So it's 50. Okay. So now scarce resources is the direct labor, and how many labor hour required for the providing one service of R. So we do have given the labor rate and total labor cost, so we will divide both two. So total labor cost is 20 and rate is 25. So 8, 35 divided by 25, 1.4, 30 divided by 25. So now contribution per limiting factor, so it will be like this, copy paste it over here. So which of the services is generating the higher contribution per limiting factor? So we will rank accordingly. Highest one is for the T, so first, after that R, it will be second, and S will be third. Okay. So which is the most profitable? T, and least profitable? R. Okay. Sorry. Least profitable will be S. It's my mistake. That we have ranked already third to the service S, so it will be the least profitable. Okay. So next, 103. If extra 20 kg of material Z becomes available at 2 per kg, what will be the maximum increase in contribution B? Okay, so it means material is the scarce resources, I think. So let's read out the scenario, or the question is, linear programming model has been formulated for two product x and y, and objective function is depicted by the formula c equal to 5x plus 6y, where c is the contribution, x is the number of product x to be produced, and y is the number of y to be produced. Each unit of x uses 2 kg of material z, and each unit of the y uses 3 kg of material z. The standard cost of material Z is 2 per kg, and shadow price for the material Z has been worked out and find out to be 2.80 per kg. So as I told, shadow price is our increase in contribution for the one more additional unit of scarce resources available. So here how many unit of the scarce resources are available? It's 20 kg, and shadow price already given, so no issue. What we will do? 103. So shadow price is 2.80, and what's how many extra kg of material Z become available? 20 kg. So it will be 56. So it means our contribution will be increased by 56. Okay. Okay, next, which of the following statement is likely to be true for the company? An organization is experiencing a shortage of resources and has a graphed a potentially linear programming solution, which so is first product television on the horizontal axis. Horizontal axis means like x-axis, and the other product tablet on the vertical axis means y-axis. So ISO contribution line to solve the linear program is very flat and downward sloping. So which of the following statement is likely to be true for the company? So first is contribution per unit of tablet computer must be higher than that of the television. Contribution per unit of television must be higher than that of tablet computer. The contribution per unit of for each type of product is very similar, and the contribution per unit of one of the product must be negative. So last two options obviously it won't be possible. So because the iso contribution or the slope of the iso contribution line is obviously determined by the contribution per unit of the each product, and the question told the iso contribution line is flat, right? It's flat and downward sloping, so it obvious that the product on the vertical axis must have a more contribution than the product which are on the x-axis, right? So what is the product which are on the y-axis? It's I think tablets. It more obvious that tablet have a higher contribution than that of the television. So it will be the option, I think, A. 105. Which two of the following statement about linear programming are true? Okay, so a linear programming model has been formulated for the two products A and B manufactured by JCO. A JCO can use linear programming if it start to manufacture the another product C. So it is not true, because it is linear programming will only applicable when there are two products. Okay, JCO company need to use linear programming if there was not a demand constant. They can use if there is demand constant. Okay, so this is false. GKO company should ignore fixed cost when making decision about how to utilize production capacity in the short run using the linear program. This is obvious true. You can read this straightforward line in the assumption of the as well. So this is, I think, correct. So linear programming model can be used when there is unexperienced curve once the steady state has been reached. This is obviously okay. Question asks two. Oh, yeah, I was wondering how could be the two option will be right at once. The question asks two. Okay, so both are correct. Okay, last two options. Okay, so what the last option was telling, the linear programming model can be used when there is experience curve once the state has been reached. Steady state means constant, and if steady state has been reached, it means variable cost will be the constant. What's our next question? How many unit of product A are produced in order to maximize the contribution? This is the same as we did above. I think it's first number question. I think that 8,000 unit of Y. Yeah, it's like 98. So I will say just give it a try. In case of any doubt, do let me know. Now you can follow me in the Instagram as well, and you can message me on Instagram or Twitter or Facebook or in the Telegram. Okay, so next, what is the maximum number of unit of product B which can be produced? Okay, so graph has been given. All constant have a less than or equal to constant, means our feasible region will be towards the origin, right? So we can see there are three constant given. So one, the last one, which is more close to origin, will indicate our feasible region. Okay, and so for the product, maximum number of product B could be produced will be it will be, I think, 60. Okay, so this is not the iso contribution line. The question didn't tell about this. Just don't get confused with the iso contribution line. Okay, so this is also one of the constants. So, and this is more close to at the origin, so feasible region will be within the this portion. So I guess 60 will be our maximum number of unit which could be produced. Okay, 108. What the requirement? Which of the following resources have a shadow price greater than 0? Shadow price greater than 0. Okay, so shadow price. So in case of slack resources, our shadow price will be 0. Okay, and so question is, organization has created the following linear programming solution to represent the position it faces currently in the presence of scarce resources. The feasible line is represented by the area dot 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 ABCD. And the node DL is direct labor hour. The point marked B has been determined to be a point which provide the optimum production plan. So B is our optimum point. Okay, so what the question has told, which of the following will have a setup price greater than 0? So we do have a lots of constant here. One is material B, material A, machine hours. So R equal to 500, direct labor hours T equal to 800. So as I told, in case of slacks resources, the shadow price will be 0, and the optimum point is on the B. So whatever the line which is apart from, far away from this point are, it means they are having a slack. So material B have a slack, material A have a slack. So only the shadow price will be greater than 0 will be for the direct labor. Okay, because it is on the optimum point, you can see, and rest other line are apart from this production optimum point, so it means there is slack present. Okay, oh, I think this is clear. So I think this is last question. Okay, so in next video we will do pricing decision question. Okay.